All right, let's go over this warm up so that we know that you are ready for your quiz. So here we go. On your notation, okay, it might help to kind of group some things together. So here we have these three standard deviations. And so one of them is from the population, and that would be number 3. Okay, standard deviation of population. And then you look at these two, and one of them has to do with sample proportions and sample means. So you can see that the X bar is your sample mean, so that's the standard deviation of sample means and the standard deviation of sample proportions. Okay, so grouping things together like that can help. Also, like I'm going to even skip down here to 9, 10, and 11. This groups the means together. So this mean without a subscript is that mean of the population. And then here we have the two different means of sampling distribution. So this one is the mean of the sample proportions. And here we have the mean of those sample means. All right, then let's take a look at those middle ones that are kind of the oddballs here, 4 through 8. Well, 4, just a regular X, that's just your individual piece of data that you'd find in your population. But then you might have a sample. N is the size of that sample, so the sample size. And then here's your X bar. So if you average all of those X's together, then that's the average of your sample mean. So your sample mean. Now look at the difference between your P and your P hat. Your P being the population proportion, but that P hat, that's your particular sample proportion that you got in your particular cup of M&Ms, okay, your P hat. All right, and so then this is a reminder of those formulas that we're going to use on the next page. So there's that formula for the, actually we don't do proportions on this quiz, but here is the formula for the standard deviation of those sample means. So here we have this problem. And so when we read this prompt, it's about the weights with a population mean and standard deviation of those. We are not told that the population is normally distributed. What this tells me is that I'm not allowed to do normal model math about one single backpack. I'm not able to say, what's the probability that a backpack will exceed 17 pounds? Because I do not know the shape of all of the individual weights. But this question asks about the average weight of a sample of 30. So that's asking about what's an X bar. Okay, so that's then why we come down here and we have, so because this we are not told about the population, but because we have a sample mean that is large, a sample that is 30 or greater, then that will turn this into a yes. So then that allows us to do our normal model math. Okay, and so that mean is going to be centered in the same place. But see, here's that formula. That standard deviation is that standard deviation from up above divided by the square root of n. So then we have our z-score. And so then that's that x bar. See how far that sample is away from where the center of all the x bars are supposed to be. And then that standard deviation of your x bars, so that's -1. And it asked about exceeding, so that's heavier weights. So that's why I went greater than -1. So that's 84.13%. So that means that when I did the math to get that percent, I did the norm CDF from -1 to +99 to get that area. Okay, and then this next one here, we have a situation where we were talking about the average duration of marriages, first marriages here. So the average is 7.8 with a standard deviation of 1.2. We are not told that the population is normally distributed. So again, what this tells me is that I do not have the right to ask about the probability of one marriage lasting between 7.9 and 8 years because I do not know the shape of individual marriages. But this problem asks about samples of 75 divorces and the average of those 75 divorces. So then that means we have this. So again, remember that we were not told, but because our sample size is large enough, it turns the sampling distribution shape into yes, it is normally distributed. So now we have the right to do the normal model math. Well, we know we're centered at 7.8 and get the correct standard deviation. It's the population 1 divided by the square root of n. And we wanted to find the x bars in between the averages in between 7.9 and 8. So we had to do two z-scores, a z-score for the 7.9 and a z-score for the 8. And those were our z-scores. So I got this area, I norm CDF'd from the lower one, 0.71, up to the upper one, 1.43. And so that's how I got the area in between those two. And that's 16.25%. Okay, I think that is all of that warm up. So I hope that you are ready for your sampling distribution on means quiz.